Hey guys, week 5. Um, your coursework calls for the use of multiple vanishing points. And this is the first time we are seeing multiple vanishing points. Please check out in your course content folder, supplemental materials. You've got some handouts in there that talk about multiple vanishing points. So far, everything we've done, the boxes have been lined up parallel to each other. As you have figured out, that's not always going to be the case in real life. Check out your top view of everything lined up parallel, so they all will share a pair of vanishing points in two-point perspective, as opposed to boxes that are scattered about, which all have their own vanishing point in 2-point perspective. Now, this is kind of a difficult concept, but stick with me here and we will see how this works. All vanishing points are on the horizon still, but each object now has its own set of vanishing points. This is brand new to us. So I'm going to try to show you in InDesign how this works when you have multiple objects that are not facing the same way. So let's get into the coursework. You'll all download this image, print it out if you need to, and draw on it. But you're going to spend a couple of hours just trying to recreate this image. And I know it looks like a huge leap, but we need to simplify and think of it in terms of these are just boxes. We know how to use boxes. We've been drawing boxes all semester, so this is just the same thing. Just like boxes have a horizon, this image has a horizon. Let me remove some of these. Now I've gone and determined that our horizon is just about up here. The reason I determined that is the slope of that line and that line. This is the only, well, this one too, but on this entire image, these are the only lines that slope down toward a vanishing point. Everything else has an upward slope. So that's how I determined horizon. But either way, I have found vanishing points for every object. So first let's take a look at the chair. You can see we've got 2 vanishing points correctly on the horizon, because as we know, vanishing points are always on the horizon when all the objects are flat, which all these objects are flat. This chair is flat on this table, this box is flat on this table, and this birdhouse is flat on the chair. Now the chair is an irregular shape, but remember with the roof of the birdhouse facade, I said to sort of think of everything as contained in a box. That's all we have. The chair is just, a tall box. And just as we know how to find the vanishing points when dealing with a plain box, we can apply that same exact theory to the chair. And you can kind of see in here how I've found that. I'm thinking of the chair, leave the outline on. I'm thinking of the overall sort of outer container box of this chair. From the bottom of the legs all the way to the top of the back. And whatever that says. So I've gone ahead and found 2 vanishing points that indicate our viewing angle of this chair. Pretty simple. Now, let's take a look at the box below. You can see that this box is not going to follow the same vanishing points because it's not sitting at the same rotated angle as the chair's box. So now, for the first time, we're dealing with a second set of vanishing points. And one happens to be very far away. So I hope you can see this. The blue is our chair vanishing points, and the orange is our box vanishing points. And as you can see, the box's vanishing points are very much different than our chair's vanishing points because of the distance from the center of vision. Now I'm calling this the center of vision. I just sort of figured that out using perspective, and you will see how that works in a second. So what we have is, as you know already, a vanishing point that is closer to the center of vision has the opposite vanishing point further away from the center of vision. In this case, it's like way out there. So as you can see from the chair vanishing points, they're just about equal on either side of the center of vision. So in addition to the chair box and its radials emanating from its viewpoints, and the box, which has its own set of radials emanating from its vanishing points, we have a third set. Now this is that birdhouse. Birdhouse has its own set of vanishing points, and one happens to be, and let me zoom in, I've found that by figuring out where one of the viewpoints is by following these radials backwards, these obliques, and determine that that's the angle of our overall box. Just like when we did the facade, we thought about it inside of a box. So what's going on with these viewpoints? You'll see one of them is very close to the center of vision. So what happens to the other one is it's way further away from our center of vision. Because again, the closer one viewpoint is to the center of vision, the further away the other viewpoint is. Let's take a look at viewpoint 4. This box right here. Let me zoom in. We're looking at this box, which the top view is this box. We can see one vanishing point is getting close to our center of vision here. So the other vanishing point for this set of box 4 is further away. Box 2, vanishing point is slightly further away than 4, so the other one is slightly closer in than the other one. And here's why. So here's all of our viewpoints and our radials emanating from our viewpoints to our objects, which are really just boxes. And remember, I mentioned something about a 90-degree relationship between viewpoints. Here's what I'm talking about. So our center of vision is here. That makes us our station point. Our face is right here looking at this scene within our cone of vision, remember. So we've identified a station point, and we could see that our viewpoints for the chair are 90 degrees. This is a 90-degree perfect right angle right there. What happens now let's take a look at the orange box here. Now that one viewpoint is closer to the center of vision, this whole 90-degree angle simply sort of pivots over this way. And now viewpoint 1, or vanishing point 1, and vanishing point 2, which is way out here, are still at 90 degrees from each other. You can see those overlaid on top of each other. Chair, box. Remember, we've got a third set. The birdhouse vanishing points are 90 degrees from each other also, which puts viewpoint 1, that should say 1, way out there. I mean, like way out there, because viewpoint 2, or vanishing point 2, is so close to the center of vision that the 90-degree relationship between the two vanishing points puts it way off the page. But I'm never going to ask you to draw this stuff, these 90-degree angles, but just so you can see, just so you could further understand what I'm talking about when I say 90 degrees. So I hope you can see this. I'm going to remove our box outlines. Again, we've got a horizon, we've got a center of vision, we've got one set of vanishing points for the chair. We've got another set of vanishing points for the box, one of which just happens to be way out here. And a third set of vanishing points for that birdhouse, where one happens to be way out this way to the left. 3 objects: chair, box, birdhouse. 3 sets of vanishing points: chair vanishing points, box vanishing points, and birdhouse vanishing points. It's the same as if they were boxes on a table. Hopefully this helps you understand multiple vanishing points a little better. I know this is sort of difficult, but rewind, pause, take a look at those supplemental materials, and I think you'll get this. And as always, please just email me if you're stuck. This is just going to be coursework. It's not as graded, or it's not graded as harshly as homework, but I just want you to understand this concept, because objects in real life are never going to line up the way our convenient art school boxes do. So you need to learn multiple vanishing points, and this is a huge step in learning perspective. It's going to take you a little bit to understand this, but hopefully this helps, and I want you to work with me, and please let me know if you're running into any problems. Let me do some simplifying here. Okay, I'm just going to show you some simplified versions. I'm not even going to talk. Alright, guys. I really hope that helped. One other thing. As we know, so far, this semester, all of our verticals have remained verticals in 1-point and 2-point perspective. Since this is 2-point perspective, our verticals stay vertical. At no point. Now, okay, there's a little distortion in the photograph, but I want you to ignore that, and I want you to draw every vertical perfectly vertically. At no point do any of our verticals in this image tilt off to one side. Verticals remain vertical. If I see any verticals that are not vertical, I'm going to scream. But you guys get that by now. So far, all the work we've done this semester, every vertical on the page stays exactly vertical when we draw it. And again, we are going to draw volumetrically on the homework, which means draw it like a glass box, like where we can see what's behind everything, as if it's invisible or clear. Don't worry about shading. I want to see all made up sides of the boxes, right? Like you can see through everything. I'm just going to do that real quick. You know how to find the center of the birdhouse, right? So you can make that peak. You know about vanishing points. You're going to use them. You're not going to draw your vanishing points because that'd be impossible. But you are going to use your intuitive knowledge of perspective to know what direction these vanishing points head off in. See? But again, verticals, verticals, verticals.
Verticals, 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 verticals. A vertical, always.
Always. All right, thank you.